In this section, we are going to talk about consumer and producer surplus. But before we do that, we need to talk about demand and supply curves. And to illustrate a demand curve, we're going to start with this first example. Demand is the quantity of a product that consumers are willing and able to purchase at various prices. The following shows the demand for cups of coffee in a small town. Now, looking at the table, we could see the price per cup. If a cup of coffee costs $5, then the quantity demanded will be 10. If the price gets lower to $4, then the demand will go up. They will now sell 20 cups. If the price continues to go down to 3, 2, and 1, you could see how the quantity demanded goes up. And that actually makes sense for us as consumers. Think about if you're on your way to work and you're going to pick up coffee for yourself, but coffee costs $1. You're like, hey, I'll bring in coffee for everyone instead of just myself because it only costs $1. Additionally, with this table on the right here, I have put up a graph of the demand curve for coffee. And this is just the points connected with line segments. In reality, we'll have a function for our demand curve. On the horizontal axis is the quantity demanded, and on the vertical axis is the price. When the price is $5 here, the demand is lower. And as the price goes down, the quantity demanded is going up. If you have taken economics before, you will recognize this demand curve. If you haven't taken economics, when you look at this graph, it might seem opposite of how you would normally set it up. Mathematically, it makes sense to put the price on the horizontal axis and the quantity on the vertical axis, but that's not how they do it for supply and demand curves. The way you're seeing it is the way that they do it in those classes. Okay, let's talk about supply. Supply is the quantity of a product that producers are willing and able to bring to market at various prices. Now we're going back to our coffee example, but now we're taking the perspective of the supplier. At $1 a cup, we're not going to make a lot of money on $1 a cup. So maybe we only bring to market a quantity of 10. If we can sell it for $2 or $3, then we will prepare more coffee so that we can make more of a profit. You'll see on the table, we've increased the quantity to 25 at $2 a cup and 45 at $3 a cup. And as you see, at $5 a cup, the quantity demanded is going to be 90. We're going to produce more because we can sell it at this higher cost. So if I want to sell it at a higher price, I'll produce and sell more. Now, what they do in economics is they put both of these curves on the same axes. So let's go ahead and label these. The first one that is going down, this is the demand curve. And we use D of Q for that one. And then the green one going up, this is the supply curve. And we use S of Q for that one. What we want to study is this point right here. That is the equilibrium point. The equilibrium point is where the supply and demand curves intersect. This is the ideal point at which sellers and buyers come together, where purchases and sales actually occur. To find the equilibrium point, we want to set supply equal to demand. Q is the input, or to relate it to algebra, the X. Q is the quantity. Then we want to put Q in either function. In the problems that we'll look at, we'll have two functions. We'll have a demand function and we'll have a supply function. So we'll put the Q in either function to get the price. Price is the output. Okay, let's put all this together with an example. This example discusses the vintage sneaker resale market, which has exploded in recent years, with rare kicks from the 90s and early 2000s commanding serious prices. In a particular online marketplace specializing in vintage Air Jordans, market analysts have determined that the monthly supply and demand for a specific rare model follows the following equations. We have the demand curve is going to equal negative 2q squared minus 6q plus 260. And the supply curve is going to be S of q equals q squared plus 4q plus 92. Q is the quantity in pairs sold. And then the output will be the price. Part A asks, at what quantity and price does supply equal demand? We're trying to find where demand equals supply. To do that, I'm going to go ahead and set these two equations equal to each other. Negative 2q squared minus 6q plus 260. This is going to equal q squared plus 4q plus 92. Now, we have a lot of algebra going on here. I'm going to subtract all the terms from the right-hand side. So I'll get negative 3q squared minus 10q plus 168. I'm going to set that equal to 0. Now, to solve this, you have lots of options. I prefer factoring because I think it's faster and I make less mistakes. You can do it that way, or you can use quadratic formula would be the two options. The first thing I'm going to do is factor out that negative to make it easier. I get 3q squared plus 10q minus 168. And when I factor, I just like to use the AC method. So the A term is 3 and the C term is negative 168. If I multiply those two together, I get negative 504. So I need to find two factors that multiply together to be 504. And when you add them together, they are positive 10. Now, I did have to use my calculator to check some of these factors, but I found that 12 times 42 is 504. I also found that 14 times 36 is 504. And then I also found that 18 times 28 is 504. Well, if I make this one negative, so I get negative 18 times 28, that will be my negative 504 that I'm looking for. And if I add them together, I get this positive 10. Now I'm just going to rewrite this as 3q squared. And then instead of the 10q, I'm going to rewrite it as minus 18q plus 28q. And then I'll keep that negative 160. Now at this point, I can divide out that negative from both sides. And when I divide 0 by negative 1, it just is still 0. Now I can factor in two groups of 2 to get 3q. And then what's left over is q minus 6 plus, in the second group, the 28 factors out, and I get q minus 6. And now I have these two factors of q minus 6, and then I have 3q plus 28 left over. Now I can set each of these factors equal to 0 and solve. So I get q equals 6 and q equals negative 28 thirds. Well, the negative 28 thirds isn't going to work because we can't sell negative 28 thirds sneakers. So Q equals 6, the quantity equals 6, which is what I have over here in the graph. The equilibrium quantity is going to be 6. Now, to find the price, I just plugged this 6 into either my supply function or my demand function. The demand at 6 is going to be negative 2 times 6 squared minus 6 times 6 plus 260. This is going to be 152. The equilibrium point will be 6, 152. This is the number of sneakers will be sold at this price, $152. And you can see I've got it marked. The output here on the graph is at 152. That is how you find the equilibrium